Welcome to the Interval 0 RTX Quick Start video. In this video, we will show how RTX integrates with Microsoft Visual Studio, create and build a sample RTX application, and run the application in the RTX subsystem. RTX requires very little to get started. All you need is 32-bit Windows XP or later, and Microsoft Visual Studio 2005 or later. You can use the RTX Software Developer Kit to develop real-time applications. RTX SDK includes header files, libraries, as well as Microsoft Visual Studio support, which integrates seamlessly with the Microsoft Visual Studio IDE. Because RTX SDK is based off of Win32 API calls, the RTX development environment is familiar to Windows developers. RTX integrates with the New Project menu in Visual Studio by adding templates for creating an RTX application, device driver, and network driver, which you can access from the Visual C++ branch under Installed Templates in the New Project window. Just select the template you want to use, provide a name for the project, and click OK. The templates utilize the RTX application wizard to help you get started. The wizard provides basic project settings, as well as compiler and linker options, which are covered in the RTX documentation. In the application settings screen, you can accept the current settings or configure additional options in the wizard to customize your project. Here you can specify whether to generate an RTSS application or an RTDLL project. RTSS is the extension given to real-time applications that are built to run within the RTX subsystem. Think of it as the RTX real-time equivalent of a Windows exe file. RTDLLs are the RTX version of dynamic link libraries supported within the RTX environment. For this example, we will build an RTX application. You can also specify a string convention on this screen and whether to add support for RT TCP/IP and RTX provided support for the Microsoft C Runtime library, of which RTX supports a subset. The supported calls are covered in the RTX documentation. The wizard can provide a framework for your program, including source code and header files, which you can then modify and expand upon to create your application. For this example, we'll create a periodic timer thread, so we'll select it from the wizard to add its elements to the program framework. If we look in the new program.c file, we can see startup source code that is similar to what you would see in a Windows console application. We can now add code to the source file. The first thing we'll do is change the timer duration specified in 100 nanoseconds from 500 microseconds to 1 second. Next, we'll paste in code to expand the test duration, and we'll also enter a message to display upon timer completion. Now we'll open the function source file and add code for the function RTGetClockTime, which will retrieve the current time and print it in a message in the timer handler routine. For a more complex example of how RTGetClockTime is used to measure timer response latency, look at the SRTM sample available from the samples folder in the RTX installation directory. We'll also add the status message Hello World to display when the application is running. We'll see this message and the RTGetClockTime output values in the RTX server later. RTX adds two new configuration types to the default set in Microsoft Visual Studio: RTSS Debug and RTSS Release. We can use these configurations to build a debug or release RTSS or Windows application. .exe for the Windows version that runs in the Windows environment, and .rtss for the RTX version, which runs in the RTX subsystem. Both configuration types use the same source code and require no code changes. In this example, we'll create an RTSS debug build, which will generate a .rtss file. We'll use the Build Solution option from the Build menu to build our application. Once it succeeds, we can look in the output directory and see the .rtss file that we just built. We'll run this process later using the RTSS run utility. RTX also adds a debug add-in to Microsoft Visual Studio. The The RTX toolbar contains features that allow you to configure the debug add-in. The first of these is the RTX debug configuration option, which you can use to configure local or host target debugging. You can use the RTX debugger property settings to determine where memory is allocated from, and to set ideal processor and processor affinity for the application and debugger threads. Also from the RTX toolbar, you can view the complete RTX help, as well as about information. RTX is set up for Visual Studio debugging, but you can configure alternate debug settings in the RTX Properties control panel. To debug our application, we'll add a breakpoint to our code and select Start Debugging from the Debug menu. And as you can see, we've hit our breakpoint. We can now step through the code. Note that RTX provides access to the standard Watch and Threads windows, among others. RTX also installs several sample solutions to help you get familiar with building RTSS applications, including the SRTM sample mentioned earlier. These are available from the Samples folder in the RTX installation directory. You can learn more about them in the RTX documentation. Now that we've built our RTSS application, we can use a few of the RTX tools available from the RTX Tools submenu to run the application and view status messages. We'll also look at RTX Analyzer, a support tool that outputs system information. RTX provides its own task manager called RTSS Task Manager, which shows all running RTSS processes and loaded and unloaded registered RTDLLs on your system. Here you can see we have one task currently running. RTSS Task Manager also allows you to start and stop tasks. We'll use the Start Task option to launch our sample application. This opens the RTSS Run utility, which you can use to run an RTSS process in the RTSS environment or register an RTDLL. When you run an RTSS process, you can optionally configure a few settings. For instance, you can enable the Use Local Memory Pool setting to use deterministically allocated memory from the local RTX memory pool, without having to request memory from Windows. On dedicated systems, you can set the ideal processor or processor affinity for the application you want to run, and specify the set of processors on which threads spawned from the ideal processor may run. To run our sample application, we can browse for the output directory, or select it from the RTSS Run dropdown if we ran it recently. Note that you can also run a .rtss application from a command line using rtssrun.exe. Now that our sample application is running, we can see it listed in the RTSS Task Manager. On multiprocessor machines, RTSS Task Manager also shows the ideal processor and affinity mask for each running process. When you run an RTSS process, the RTX server appears. RTX server displays and logs print messages from all RTX applications and RTDLLs running in the RTX subsystem. It is similar to Windows console applications, but RTX Server will output console data for all running RTSS applications to the same window. Here we see the status message Hello World, as well as the output from the RTGetClockTime code we added to our project back in Visual Studio. Lastly, we will look at RTX Analyzer, which is a diagnostic tool used for retrieving information that can help in evaluating system status and identifying potential system inefficiencies or other problem areas. RTX Analyzer takes a few moments to collect and process data. Once it's finished, it outputs a timestamp.txt file. This output file contains helpful system-specific data, including information on operating system, RTX installation, and Microsoft Visual Studio. It can optionally include system latency information. This concludes the RTX Quick Start video tutorial. For more information, see the Quick Start section in the RTX documentation, available from the Start All Programs Interval 0 RTX submenu, as well as our helpful mini tutorials and videos available online at www.interval0.com/support. Thanks for watching.